Good morning, everybody. We're going to continue looking at slopes today and calculating slopes of tangents, but we're going to learn how to do it more mathematically than where we just tried to draw a tangent line and guess what the slope is. We're going to actually talk about mathematically how do you do this today. And the main reasons for this is I'm sure some of you all from working the previous problem set figured out drawing a tangent can be time consuming. It can also be a little bit inaccurate. Like you have to make sure that you're drawing a perfect line, got to have a ruler and all of these other things. So what we're going to do is we're going to develop a more perfect math definition for this. So if we've got a function here, and this is just some function, we're just going to use f of x to represent this. And we got an a right here, and we've got a b right here. The way that you would calculate the coordinates, so the coordinate for big A here is just the coordinate little a, and whatever we get from the function by substituting in a, f of a, and then we scoot over some horizontal distance here, h, that's just going to stand for the horizontal distance we're sliding over. Well, the x coordinate of b, of the point B here, we're going to just add that horizontal distance to a to get a plus h, that's the x coordinate, and we're going to get the y coordinate, we're going to plug a plus h into whatever function f of x is. So the way that we would calculate the slope, the tangent slope here, is that we are going to move point B closer and closer and closer and try to calculate the slope there. So that means that this horizontal distance here is going to get smaller and smaller and smaller and smaller, and we're going to take it to be as close to zero distance as we mathematically can. And so what we're doing when we're doing this, we're actually, as this approaches closer and closer, we're finding mathematically what is called a limit. And this is what we're going to use to calculate the tangent slope today. But before we do that, we need to understand what exactly a limit is. So we're going to get a little bit of work with limits first, and then we are going to go and apply this to calculate some slope. So if we've got an x that we're going to let closer and closer to some value that we're just going to call a here, we can make the function, whatever f of x is, become as close as we want to that value. And the way that we denote this is that we say, you read this as the limit as x approaches some number for a function equals a. Now, the thing is, when you're doing a limit, this doesn't tell you what the actual value will be. This just tells you the value that it is approaching. And so let's look at an example of this to get some familiarity. So to explain why we don't know anything about the exact value, let's say we're doing the limit as x approaches 0. That's how you read that. The limit as x approaches 0 of 5x plus x squared divided by x. If we substitute in x, if we say, okay, well, what happens when we punch in 0 for x? Well, we're going to get 5 times 0, which would be 0, plus 0, which would be 0, divided by 0. And if you do 0 divided by 0 there, you're going to get undefined. 0 is the one number that we cannot divide by in math. And so what that looks like if you physically try to divide by 0 here, it's going to say error. You cannot divide by 0. However, to figure out the limit here, we can do a little bit of math to simplify this, because in this numerator right here, there's a common factor of x right here. There's a common factor of x. So if we factor that out here to get x times 5 plus x divided by x, and then we say, wait a second, we factored and now this thing can simplify. Well, this is going to simplify to 5 plus x. What happens if we try to do the limit there? If we do the limit as x approaches 0 of 5 plus x. If I plug in 0 for x, I'm going to get the value 5. So even though when you punch in the physical number of 0 there, if you evaluate the limit, if you do a little bit of algebra, I'm going to see if I can pull up the graph real quick to demonstrate this. Is it going to show the whole? I don't think I can get it. That's okay. So anyways, if you evaluate the limit, it will work out to 5. I couldn't figure out how to get on the calculator. I apologize. So let's take a second and look at a couple of limits and see if we can do some math to get these things going. So if we look at the limit of x as x approaches 2 for x squared, there's nothing we can really do to substitute in here. So we're just going, to simplify this, so what we're going to do is we are just going to substitute in 2. So that's going to give us the value of 2 squared, which is going to be 4. So then we look at the next one here. If I substitute in the value of 0, we get 0 squared plus 3 times 0 divided by 0. That's going to be 0 divided by 0. So anytime you're dealing with this 0 divided by 0, you need to try and see if there's anything you can do to simplify this, to try and get rid of that. So if we look at the numerator here, they've both got a common factor of x. This is x squared, this is 3x, and we can factor that. So we're going to reevaluate this limit of x times x plus 3 divided by x. And now those x's can cancel, and if we evaluate the limit, we're going to get 3 when we substitute in 0 for x. So that's going to get closer and closer and closer to the y value of 3, and then it is not going to, but that it won't be the actual value if you substitute it into that function. That's what the limit is saying. As x gets closer and closer and closer to 0, this is the y value it's going to be approaching. So let's look at one more real quick. So we've got the limit as x approaches 4 of 2x squared. 2x squared minus 8x divided by x minus 4. So if we try to substitute in 4 off the get-go, let's see, 2 times 4 squared minus 8 times 4 over 4 minus 4, we're going to get, that's 32 minus 32 over 0. That's 0 over 0. So we need to see if we can do any sort of math, because that's an undefined limit, which you can have undefined limits. But we need to check to see if there's anything that we can do. So I'm looking, the denominator doesn't really look like there's anything that I can do to it. The numerator, we've got 2x squared minus 8x. What's common in both of those is I could take out a 2 and I could take out an x. I could factor those out because that's what's common in both of those terms up there. And that would give me x minus 4 divided by x minus 4. And so what we could do is say, okay, well, those x minus 4s are going to cancel out. So as x gets closer and closer to 4 for 2 times x, the limit is going to be 8. So it's going to get closer and closer and closer to 8, but it's not, but that coordinate 8 won't actually be on there. Won't actually be on there at that point, at the x value of 4. So when we're evaluating a limit, all that we're doing is we're evaluating what happens when a number gets closer and closer and closer to a certain number. That's all that a limit tells us. Now, what we're going to do is we're going to use this concept of a limit to help figure out the slope to help figure out the gradient of any tangent line using mathematics, not just eyeballing it. So what I need you all to understand, we're going to be using, this big A right here is referring to a set of coordinates. So we've got point A right here that we're going to denote with a little a, and we're just substituting into some function f of x. So we're saying f of x here. So then to get the y coordinate, you just plug a in to f of x. Now, going back to our definition earlier, let me pull this back up. This graph right here, we're saying B is some horizontal distance away from this little a. We don't know what the horizontal distance is. We just know that it's there because they're not the same point. They've got to be different points. So the x coordinate for this B value right here is a plus h. And then to get the y value there, we're going to plug a plus h into f of x. And so if you've done the bell ringer, that should make a little bit of sense on what that looks like. So now, if we want to calculate the slope between these points, if we do y2 minus y1, we're going to do f of a plus h minus f of a divided by x2 minus x1, a plus h minus a. And what you'll notice here, these a's are going to cancel out because we're doing a minus a. And up top, what I need you all to understand, these a's can't cancel out because this is what is being plugged into this function. This is what is being substituted into that other function. We need to have a good understanding of that. So the mathematics to find the gradient between 2 points where there's some horizontal distance, we're going to do f of a plus h minus f of a, and we're going to divide that by the horizontal distance. And so to find the gradient of any tangent here that we worked on last class where I had you all draw the lines, the distance between these two lines has to get smaller and smaller and smaller and smaller till they're at the same point, and we're calculating the slope at that point. So what we're going to do to calculate the slope today, we're going to use this right here to find the gradient, which comes from just using these two sets of coordinates into the slope formula. And we're going to take the limit as the horizontal distance approaches 0. So what happens when A and B get closer and closer and closer and closer, and whatever number we get as the result of that, that is going to be our slope at that exact point. So it is just a little bit more algebra intensive. This is some of the first algebra we've done probably all year. So if you have any questions as I'm going over this, please feel free to swing into the Zoom, ask me, we can look at it together. When you're first looking at this, it can be just a little bit confusing. So what we're doing here, we're going to find the slope, find the gradient of a tangent to x squared at the point 2, 4. So mathematically, what we're doing here, if we've got the coordinate x squared, I think it's important to visualize what we're doing. So we want to find the tangent line to this point right here. So like maybe if we drew it like that, except now we want to use math to do this. So the coordinate that we're given here is 2, 4. So we've got 2, 4. Now the other coordinate that we've got on this, we don't know what it is. It is just 2 plus some horizontal distance. There is some amount of horizontal distance here. So if I do 2 plus h, if I substitute this point into x squared, I'm going to get the expression 2 plus h squared. That's physically what I'm going to get there. And so the way that we need to think about this, this right here is my f of a plus h. This right here is my f of a. Like, and A is just the coordinate 2 here. This right here is my A. This right here is my A plus H. This is how we need to think about this stuff. So we're going to substitute this in. We're going to take the limit as the horizontal distance approaches 0. We're going to say of 2 plus H squared minus f of A, which is 4, divided by H. And we need to take this limit. So but before we take that limit right now, if we substitute that in, we're going to get 0 divided by 0. So what we need to do is do a little bit of algebra. So I'm going to expand this. So we're still taking the limit as H approaches 0. We haven't done that yet. Of 2 plus H times 2 plus H minus 4 divided by H. And so we're going to have to FOIL here. So let's see, if I do 2 times 2, that's going to give me 4. That'll give me plus 2H plus 2H plus H squared minus 4. And this is still divided by H. We're doing the limit as H approaches 0. So let's clean this up a little bit. So this 4 can cancel out with that 4. And we're left with H squared plus 4H divided by H. We're still going to take this limit here in just a second. And what we can see here is if we factor out an H, so we're going to get H parentheses H plus 4. We're taking the limit as H approaches 0 divided by H. These H's can cancel out. So really the limit that we are calculating here is going to be 8. What is the limit of H plus 4 as H approaches 0? Well, if you plug in 0 into H, substitute 0 in, you're going to get the tangent, so the slope at the coordinate at 2, 4 is going to be 4 because we're just substituting 0 in right there. And so one way that you can kind of check this, one way especially, is if you make yourself a sketch to visualize what you're calculating. And you're like, okay, is this positive or is this negative slope? Well, right here you can see it's increasing as I go from left to right, so it is positive. And if you make a more in-depth graph, you could probably see that tangent line does get very close to a slope of 4, even if it's Mr. Price's badly drawn graph. So that can be a way for you all to check those. So we're going to do 2 more of these just to make sure that we've got this down, and then we're going to call it a day for today. So let's take a look at 2 more of these. So we're going to look at the function. We're going to find the slope at these following points. We're going to find for the function 2 times x squared, and then over here x squared plus x. So let's take a look at it. So we're going to do 2x squared at the coordinate 1, 2. So what this is going to look like, I like to just make the XY table to help me visualize it. So let's see here. We've got, if we get 1, we substitute in the coordinate there. We get 2 into this function. So if I substitute in 1 plus h, I'm going to get 2 times 1 plus h squared. And just to help y'all out again, so this right here is a. This is what we get when we substitute this is f of a. This is what we get when we substitute a into f of x. This is a plus h. We're adding that horizontal distance to it. And then this is the function, this is the result of substituting in a plus h. So now, when we calculate this limit as h approaches 0 of f of a plus h minus f of a divided by h. I want to try to make it as clear as possible how we're substituting and why we're substituting. So again, what we're doing is we're finding the slope. Remember, this is the formula for our slope between these 2 points, and we're making that horizontal distance between the 2 points get smaller and smaller and smaller until just about the point where they are touching. So let's see, substituting in what we know here, we've got 2 times 1 plus h squared minus f of a, which is 2 divided by h. So we're going to have to expand this. So I'm actually going to do this just up here real quick. 2 times 1 plus h times 1 plus h. So I'm going to distribute there. We'll get 2 plus 2h times 1 plus h. Let's see, 2 times 1 is 2, 2 times h is 2h, 2h times 1 is 2h, 2h times h is 2h squared. So when I write this next line here real quick, I'm going to just write, okay, we still haven't taken that limit, but up here we've got 2 plus 2h plus 2h plus 2h squared minus 2 divided by h. So if we simplify this, we're going to get 4h plus 2h squared divided by h. And we're going to simplify this limit because we can rewrite this as what? 2h times h plus, or 2h plus 1. Hold on, Mr. Price cannot factor real quick. So if we take a 2h out, excuse me, so that's going to give us 2 plus h right here. Okay, I don't know why that was so difficult for me to look at. So if we do the limit as h approaches 0, these h's can cancel out. So what we've got, the limit as 2 plus 2h, the horizontal distance is approaching 0. If we plug in 0 there, we're going to get 2 times 2 plus 0. 2 times 2 is going to give us 4. So again, this particular point has a slope of 4. It will not always have a slope of 4, but in this particular instance, it does. And so what I want to do is look at one more, and then we will call it a day for today. So the coordinate, or the function that we're going to look at now, is going to be x squared plus x, and the point that we're evaluating it is 2 comma x. So again here, we've got 2 and we've got 6. We're adding some sort of horizontal distance there, and then we're substituting that in. So we're going to actually have to substitute in 2 places. That's going to be 2 plus h squared plus 2 plus h. And so, again, this is your f of a. This is your f of a plus h. That's your a, that's your h. So let's evaluate this. So we're going to do the limit as h approaches 0. So f of a plus h, it's a little uglier this time. It's this whole little expression right here, 2 plus h squared plus 2 plus h. And we're subtracting 6 here, minus 6, dividing by h. And we've got to do a little bit of algebra to simplify this. A little bit of algebra to simplify this. So I'm going to work this up here. So 2 plus h times 2 plus h. That's going to be 4 plus 2h plus 2h plus h squared. So let's see. If we rewrite this, the limit as h approaches 0 is going to be 4 plus, I'm going to go ahead and simplify these. That's going to be 4h plus h squared. That's what this part right here was. We've still got plus 2 plus h minus 6 divided by h. And let's combine our like terms. So we got 4 plus 2, which is 6, minus 6. So those are actually going to cancel out. 4 plus 2 minus 6, those cancel out. If we go and combine these like terms, that's going to give us 5h plus h squared divided by h. And remember, all we're doing is we're calculating the slope as the horizontal distance between these 2 points up here get smaller and smaller. So again, we are in a situation where the h's will factor out. We've got h parentheses 5 plus h divided by h. So those things are going to cancel. So really what we're finding the limit of is 5 plus h. So if I substitute in 0 for h right here, the limit is just going to be 5. 0 is 5. And so again, I want to stress what we found here is the slope of the tangent line at 2, 6. We're finding that instantaneous slope at that given point in time. So that is all of the notes that I have for today. Again, you are welcome to ask me if you have any questions. I am more than happy to help. And other than that, I hope that you all have a good weekend and stay safe in the snow.